Hi and welcome. Before we get on to this week's project, I just wanted to mention that the viewers on YouTube are pretty amazing, especially in this community. One of my viewers that always responds to my videos positively and with great suggestions, Vernon Courier, mentioned that there's another YouTuber, Richard from Making Something From Nothing, that's having a big property dispute with a new neighbor, and he's having a hard time staying solvent while he has his legal troubles. And believe it or not, Vernon set up a GoFundMe site for this guy, and so I donated. And you know, if anyone else is out there who interested in helping out another YouTuber who likes to create content, give to the community, go to the GoFundMe site. It'll be in the link will be in my description at the bottom, and give the guy a help, give the guy a hand, because we always know legal battles can be really ugly, and it's a new neighbor, so it sounds like it's problems. I don't know the details, but also his YouTube channel is kind of interesting. I just started watching some of it this morning, and he makes interesting things out of found items, so that's a really cool thing to do. And he makes some really interesting projects out of very little things he just finds, which I find really impressive. I've seen a couple other channels where they do similar things, and it always impresses me what people can make out of very limited resources. So we should support them if we can. So if you're interested, please go do that. And let's get on to this week's project. So this week's project is driven by another project. It's kind of interesting. I buy a tool because I run across a project where it seems like you'd need the tool, and that would be the easiest way to go. So I've shown how to do tapers on the lathe before by moving the tailstock. Another way to do it is with a boring head. So I purchased an inexpensive boring head. Got the wrong Morse taper on the tailstock, unfortunately. I got the 2-inch, and I think that was probably a mistake. I should have gotten the 3-inch with the 3/4 tooling in it. It's reasonably well made. It was 45 bucks from China, and the quality on the outside seemed pretty good, just based on what I saw on the website. The fit and finish is nice. This is ground and seems to mate up really well with the boring head. However, the action of the boring head is really messed up. So this guy is really smooth coming out, like you'd expect. Going back, you can barely get to go in. It wants to catch, and I played with it a little bit and haven't figured out exactly what's catching on it. But if I push the screw up where it engages, it seems to work better. Now, interesting, if you wonder how these things are put together, we'll take this guy apart so you can see. It's pretty straightforward. The top part has little cups ground into it that the screw has little, I don't know, what would you call it, little ledges that pop into those that move it forward and backwards. But apparently, maybe it's binding on the inside of the screw surface here. I can't exactly tell. When I got this guy, I took it apart, and all the surfaces were wonderfully ground. It looks like they put a 97 on both sides, so I'm guessing they match the two sides to each other. But the action is terrible. So there's 3 screws. The center one on these guys is a ball bearing that pushes directly on the dovetail. The other 2 just push the dovetail in and set how tight it slides. So it's kind of an interesting design. This action is extremely smooth. So they did a really nice job surface grinding it. I just wonder if there's a problem maybe on this guy on the inside. Oh, one thing that I did have to do when I got it is, you see how this grind here now is a bit even? It was totally uneven, like they held it at an angle to the grind wheel, so that was unfortunate. So that made things a little bit smoother, but it's still really rough. And I wonder, maybe I need to relieve these edges here or something? I can't quite tell, but it's this mating surface, when it goes at a slight angle, really bites. So, you know, the other thing is they probably didn't do the threads as tightly as they should, because this rocking motion I see here, I also get with the threads engaged, and I notice now that when it's like this, it binds. So that might explain it right there. So maybe if I relieve these edges a little bit with some sandpaper, that'll help. I don't know. We'll give it a shot. But my project for this week is this. This is only a Morse taper 3 because I couldn't at the time find a Morse taper 4, and the Morse taper 4 is what my tailstock uses. So I thought, oh, I'll just get an MT3 and use my adapter. Well, there's a problem here, because if I put this in, you notice it doesn't extend deep enough to where the removal tool will make contact. So I thought, okay, no problem, I'll just go buy a screw. This is an M12 by 1.75 screw, but this won't work because if I put this guy in, it mates all right, but the problem is that it's running into the edges. It's expecting a flat tang back here, like this here. So this doesn't fit in. So what I'm thinking I'm going to do is I am going to try my hand at turning metric threads on my lathe, which I've never done before, so that should be an interesting experiment, and then make a piece with a flat on the back that fits into this tang. So that's where we're headed, and I hope you find it interesting, because I do. I'm just really excited about trying metric threads. You can't disengage the half nut, at least not in the normal approach, and so that makes it harder to stop, because you really have to stop. Fortunately, my lathe has a brake. It doesn't have a clutch like some lathes do, where you can just disengage the clutch, which would disengage the drive of the cutter, but instead I've got a brake, and that works pretty well too, so we'll give that a shot. There are some other approaches I've seen from other YouTubers where they actually do disengage the half nut, don't let it go a full revolution, and then back it up and re-engage the half nut, which is also an interesting approach. So could try both those, but I'm going to try not disengaging the half nut first, see how that works out. All right, let's give it a shot. So first up, I'm going to face and then center drill the end of this. I'm going to reduce the diameter down to the major diameter plus the relief zone, which is going to be at least 1/4 of an inch. I need a large one because I won't be able to engage the half nut, and never having done this before, I want to give myself a little slack. So let's start with facing this guy and center drilling it in case I need to use a live center in here. Although this is 4140, so it might very well be stiff enough it really doesn't feel like it's going anywhere, but let's just give this a shot here. This 4140 finishes terribly in my experience, so I'm gonna be kind of interested to see where all this goes. Maybe I should have chosen a different material. It just seemed like it'd be a good strong material. Not that I really need one, but anyways. It's actually finishing pretty well. Okay. Just in case I need to use a center. So let's shoot for 50 thousandths depth of cut at 14 thousandths of revolution. Well, I'd say there's a little bit of deflection there. What do you think? Okay, so we're going to be the live center. All right, so let's take another 50 thousandths depth of cut. All right, here's half the feed rate, 7 thousandths of revolution. So we're looking for 3 thousandths here. Finishing pass. Up to speed, and we've lowered the feed. Which improves the finish noticeably. Okay, let's see how close we are to our major diameter. 0.468, 0.4686, 0.4688, so there's 2/10 difference there, by 1/10. So I don't think we'll do the equivalent of a spring pass here and see what happens. I actually dialed in about 6/10. So let's see what that buys us. Finish is nice. 0.4681, 0.46805, 0.4681, 0.468. Oh, that's interesting. That was different. Oh, caught a little bit of debris there. 0.46805, so half a tenth or 50 millionths. That's pretty freaking amazing. All right, so now we're gonna do the relief back here. So we're gonna go relief in about 118 thousandths. This might be a bit fast. It's feeling kind of fast. All right, let's slow this guy down a lot. That was 1100 RPM for a finish, and we're gonna switch down to 440. Wow, case hardened the outside. This stuff hardens pretty easily. It gets burnished real easily by the cutting tool. Got to be very careful with that. I can feel it because what happens is if I leave the cutter in one place too long, you see it get really shiny in there. And I don't know if you can see that, but it's really shiny in here. And once I do that, the next time I try and go in with the cutter, I have to push harder and it breaks through the surface layers. So it seems to me this annealed 4140 is getting heat treated by the cutter just sitting there rubbing. So got to be careful about that. So I could very well screw this up. Here is a 1.75 pitch thread gauge, and there's matching the screw. So that's correct. So I have the settings on my lathe right. What I have to do is I have to engage the half nut and then never disengage it again, which means every time I come to this end spot, I've just got to break it and then back out. So I am going to dial in on the compound just a couple thousandths so that I can scratch this. And we're going to run this as slow as the lathe will go, which is 70 RPM. And we're going to see if I get this right, because I've never done metric and I'm not even sure exactly how to do it. So we'll see. All right, so as soon as I can engage the half nut here, there it goes. Coming to the end, backing out. Wrong way. So now you have to come backwards each time, which I'm really not used to doing. To re-zero, got to leave the half nut engaged. All right, so let's see. Did we get our pitch right? I hope we did. That looks really good. Let's see. Yeah, that looks right on the money. All right, so I say let's go for it. So now the only way to get forward here is there. So now I can set my a little too far. So I'm going to go in back to 0 on this guy, and I'm going to go in about 10 thousandths on the compound. and stop and come out and go backwards. Go back to 0. Dial in another, say, 10 thousandths and go forwards. There's no time for screwing around with this. So I don't know how well you can see this, but I kind of screwed up the threads. And the way I screwed up the threads was a novice mistake, but it's a really weird design in my compound on this lathe. And let me show you. So as we prepare to start again, here is the marking that came on the lathe, which is utterly worthless because 30 degrees off of horizontal is 60 degrees off the perpendicular, which is not what you want. Over here I made a mark and that's 0, so we want 29.5 degrees off of perpendicular from there. So we're going to try this threading mess again. So I made another great observation. Remember I thought it was work hardening here, or it was heat treating it. It's somehow my cutter, even though I usually set these lock nuts tight, had moved off of center and was high of center by maybe 150 thousandths. So it was rubbing all the way. Bad on my part. I don't know how I missed that. I guess I was counting on it staying where I last left it, so I don't know how it moved, but somehow it did. So once I got it back on center, it cut like butter. So my bad. All right, let's shoot for a scratch pass here. Nut is engaged. That's a cleaner cut. Oh, just a little tight. I mean, that is nearly perfect. Just a little bit tight. All right, so we need to take off 1,000th or 2 more. That's it. And we'll be right there. That's perfect, though. Last spring pass, hopefully. Here we go. That's what I want to see. Clean pass. All right. Do another test fit. Get all the debris out of there. And this is the difference of 1,000th. Look at that. Look at that difference. 1,000th more depth. So this actually worked out to the way I calculated it too, which is good. Oh, perfect. Very nice. All right, great. So now we just need to do the flat and we're done. We may need to make a shim though for it, but I'm going to take you over and explain how I did the depth, because I actually was able to dial in my cross slide to within 1,000th of where I wanted to be. So I'm going to show you how I got there. Maybe it'll be useful for you. So let's see if I can make sense of this. So the diameter, or the major diameter, is 0.468 inches for this bolt, which would be the outside diameter from there to there. Okay. The pitch diameter, which is measured part way down the threads from front to back, is between 0.420 and 0.426, so I just chose 0.422. So if you subtract the outer diameter from the pitch diameter, 0.046 is how far you need to go in. And if you look at a triangle, the right triangle, here's half a thread. 0.046 is the vertical distance you have to go in, but the compound infeed is going at the 29.5, we'll call it 30-degree angle. So that means cosine of 30 is equal to 0.046 over the infeed, or the infeed equals 0.046 divided by cosine 30, which equals 0.053 inches. I nailed it at 0.053 and it was exactly right. So that's how I got from the machinist handbook data to how far to infeed on my compound to get close. One more thing I forgot to mention. This distance, infeed distance, is actually half the amount of material you'll cut off going this far in, because like the dials on your lathe, if you don't use a DRO regularly like I do, they're going in radially, and you actually take off twice that diametrically. And the pitch radius on a thread is the point where half of the thread is above and half is below. So going in twice that, you reach the minor diameter, which is where you're shooting for ultimately. You want your cutter to go all the way to the minor diameter. But so going infeed to the pitch diameter will actually be double when you infeed that far. And so sorry about that. I missed that little bit there, and that may have confused some people. So now we're just going to mill the flats, and we're going to go down 200 thousandths a side to make the right width, and that should be pretty quick. I won't show you all of this because it'll get kind of boring, but here's a couple of passes. Next, I just want to part off the piece and then I will finish it. So let's turn this guy on. And we'll ease the blade in. See how we do now. So I started with this, went to this mistake at 60 degrees, to this one at 30 degrees, and this one's great. So this guy just threads all the way in. And pops into here. Now I have access to pop this guy out. And there it is. So if I really want it to last, I'd harden it. The other thing is that you probably want this to line up in the lathe perfectly horizontally with the adjustment knob aimed at you, right? Well, maybe the adjustment knob needs to be on the back because the tightening screws are up. But in order to do that, I'll have to change the position of this to change the position of this guy so that it lines up in the tailstock right. And in order to do that, I could just make a custom spacer down here that would space this guy out just the right amount to make it perfect. And then we'd be good. So for those who are wondering what it looked like, here it is in the tailstock. The adjustment screws over here, the tightening screws are here, the tightening screw is here, the dovetail tightening screws are there. You can't really, you either have to have this upside down so you couldn't set the locking screw, or you got to have the adjustment on the back, but that's not a huge deal. And so you can see right now the alignment's right, so that when it shifts off, it'll be going off in that direction. You probably want to set that up with a bar and an indicator to get it dead horizontal, so that when you make an adjustment, it's right. Unless you're going to use something like angle blocks to set the actual angle, then it doesn't matter if it's off a little bit and it's not moving exactly horizontally. So anyways, thanks for watching. Hope you find it useful. Hope to see you next time.